Hello students, in today's lecture I will discuss about two-dimensional transformation, and in this transformation we will see rotation and reflection. Rotation is a process of changing the angle of the object. Rotation can be clockwise or anti-clockwise. For rotation we have to specify the angle of rotation and rotation point. Rotation point is also called as pivot point. It is a point about which object is rotated. The positive value of pivot point rotation angle rotates an object in a counterclockwise, that is anti-clockwise direction. The negative value of the pivot point rotation angle rotates an object in a clockwise direction. So you can see that rotation means it is changing the orientation of an object along a circular path, and for that we have to give an angle, and that angle is called as rotation angle. And if you are rotating counterclockwise direction, that means if you are rotating in anti-clockwise direction, then we are taking the rotation angle as positive, while if you are rotating the object in clockwise direction, in that case we are taking the rotation angle as negative. So you can see in the figure, this is the initial position of an object, and the object is at an angle of phi with the x-axis. Then what is happening, we are changing the position of an object from O to O dash with an angle theta, where theta is the rotation angle and O dash is the new position of an object. So initial coordinates of the point is x old and y old, and after changing the position, the new coordinates of the object are x new and y new. So consider a point object O has to be rotated from one angle to another in a two-dimensional plane. And here we are discussing about two-dimensional transformation, so we are having only two axes. First is x-axis and second is y-axis. And you have to keep one thing in your mind, the rotation that we are doing is about origin. Okay, so initially the position of an object that we are dealing, in that case the reference point is the origin. So it is all about the rotation about origin, and whatever the equations that we are seeing here, they all gives the rotation of any object about the origin. So initially the object is with an angle phi with the x-axis, and after that we are rotating the object with the angle theta, and because of that the new coordinates becomes x new comma y new. So these are the transformation equation of rotation, and in this we can see that x new is equals to x old cos theta minus y old sin theta, where theta is the rotation angle, and y new is equals to x old sin theta plus y old cos theta. So here is an example in which we are discussing about rotation of an object. You can see that here we are having one line, given a line segment with the starting point as 0, 0 and ending point as 4, 4, and we are applying a rotation of 30° in anti-clockwise direction, and finally we have to find the new position of the line. So you can see that the rotation is in anti-clockwise direction, so here theta is positive, that means 30° will be positive. And we know that as per the transformation equations, this is the formula. So directly we are applying the formula. x new is equals to x old cos theta minus y old sin theta, and y new is equals to x old sin theta plus y old cos theta. So you can see that the initial position is 4 comma 4, and finally the new position is 1.46 comma 5.46. so you can see that the position of line has been changed, and the new coordinates are 0 0 comma 1.6 comma 5.46. so this point, the initial point is already at origin, so this point is not going to be changed, because as you substitute the value of x and y as 0, the entire things become 0. So this point will not change, but the point 4 comma 4, it will change, and the new point will be 1.46 comma 5.46. So till this point, we have discussed about three transformations. I have started with the translation and scaling in the previous lecture, and in this lecture I have discussed about rotation. So you can see that translation, rotation and scaling, these are the basic three geometric transformations, and apart from that we are having two more additional transformation. First is reflection and second is shear. In reflection we are producing the mirror image of an object, and in shear we are changing the shape of an object. So reflection is basically, it is a transformation which produces a mirror image of an object. The mirror image can be either about x-axis or y-axis. So whenever you are doing reflection, you have to tell whether it is a reflection about x-axis or it is a reflection about y-axis. So reflection is nothing but it is a kind of rotation with an angle of 180 degree. So that means if we are moving an object with an angle of 180 degree, then it is a kind of reflection. So reflection can be reflection about x-axis, it can be reflection about y-axis, it can be a reflection about an axis which is perpendicular to xy plane and passing through the origin. So you can see that this is all the reflection about z-axis. And finally we are having reflection about a line y is equals to x or a line y is equals to mx plus b. So we will start from reflection about x-axis, and this is the 3 by 3 matrix of reflection about x-axis, and it is a kind of homogeneous matrix. What exactly is the homogeneous matrix, that we will discuss in the next lecture, but at this point you should keep in mind that whenever you are representing any transformation in as a homogeneous matrix form, it is of order 3 by 3. So you can see that this is a reflection about x-axis and it is represented through 3 by 3 matrix, and in this we can see that in this transformation value of x will remain same, whereas the value of y will become negative. So whenever you are performing reflection about x-axis, it flips the value of y. That means the y value changes but the x value remains the same. So you can see that ABC is an object, and this object we are reflecting about x-axis. So this object is going to shift from first quadrant to the fourth quadrant, and we know that in fourth quadrant the value of y is negative but the value of x will remain same. So in this the object will lie another side of the x-axis. Now reflection about y-axis, the object can be reflected about y-axis with the help of following transformation matrix, and you can see that in this the value of x going to be changed. In case of reflection about an axis perpendicular to xy plane and passing through origin, in this you can see that the object is in the first quadrant and finally the object is going to be shifted in the third quadrant, and in the third quadrant we know that the value of x and y both are negative. In this value of x and y both will be reversed. This is also called as half revolution about the origin. So here we are having another reflection, which is reflection about a line which is y is equals to x, and you can see that this is the line which is having slope 1 and the intercept on y-axis is 0. So this line is about an angle of 45 degree from the x-axis, and whenever you are reflecting any object about this line, you have to use this transformation matrix, which is 0 1 0 1 0 0 and 0 0 1. First of all, the object is rotated at 45 degree. The direction of rotation is clockwise. After it, reflection is done concerning x-axis. The last step is the rotation of y is equals to x back to the original position, that is counterclockwise at 45 degree. So you can see that here we have written so many steps. Whenever you are performing rotation about a line which is equals to y is equals to x, so it is not a single transformation, it is a kind of composite transformation. And the composite transformation means you are performing more than one transformation. So whenever you are performing transformation about the line y is equals to x, so this transformation involves a kind of three transformation. In this, first is rotation, then reflection about a line y x-axis, reflection about a line x-axis, and finally we have to rotate the object back to the original position. So this is a kind of composite transformation, and the composite transformations I have covering in the next lecture. So you please go through the next lecture, and in that you will get an idea about the composite transformation. But whenever any question is given, you have to perform rotation reflection about y is equals to x, you can directly apply this matrix. So here we are seeing one numerical on reflection, and in this you can see that I am having a triangle which is having the point 3, 4, 6, 4 and 5, 6. So basically what is happening in this, we have to perform a reflection about x-axis, and you know that whenever you are performing reflection about x-axis, the value of y flips. So you can see that the coordinates which are 3, 4, 6, 4 and 5, 6, these coordinates now becomes 3, -4, 6, -4 and 5, -6. And finally, the position of object will shift from first quadrant to the fourth quadrant. So this is all about this lecture. In this lecture, we have discussed about rotation and reflection. In the next lecture, I will cover homogeneous matrix representation and composite transformation. Thank you.